Okay, guys, a few things here that we want to get down in a very important concept. Today we're talking about systems of linear equations, and I'm just going to read this first part. It says a system of linear equations consists of two or more linear equations with the same variable. Basically, guys, that's saying not one equation but two or three. Okay, a system is when I have more than one equation. All right. A solution of a linear system is an ordered pair, that's an x and a y, right? That's a solution for each one of them. It solves both of them. It works for both. I'll show you in a minute what we're talking about. Okay? The number of solutions for a linear system. The possible number of solutions that an equation can have, or I should say that a system can have, are 1. They may have one solution. They may not have a common solution. Or they may have an infinite number of solutions in common. Okay? All right. Now let's look at this first one. Actually, you know what I'm going to do? I'm going to bring in a graph here because I just want to talk about this. Do you guys agree this is a line? Right? And then this one's also a line, yes? I'm going to graph both of them very quickly. Okay? The first one says y equals 2x minus 4. That means I go down 4. I go up 2 and over 1, up 2 and over 1, up 2 and over 1. And I've got a graph that looks like that. Now, guys, you'll remember me telling you that a graph is a picture of all of the solutions to an equation. Okay? So this is the blue line. Right? Okay? Now, Hobbs, I'm going to graph the next one. It's got a y-intercept of 1, and I go down 3 and over 1, down 3 and over 1, down 3 and over 1. All right, I'm going to graph this one. Okay? So this is the green equation, or the green line, right? Remember, a graph is a picture of all of the solutions of an equation. This is all of the solutions of the green equation. This is all of the solutions of the blue equation, right? What is important about that one? That one point. I love seeing all these hands go up. That's beautiful. What is that one point, Trigo? It's the solution that solves both of them. If I plug in the x and y of that point, it solves both of those equations. This is, if I give the coordinates, the x is 1 and the y is 2. I mean negative 2. So 1, negative 2. Do you agree? If I plug that in, it gives me, I mean, it's true, it's a solution for this one and for this one. Now the thing is, today I'm going to show you how to find out what this point is without graphing it. Okay? It's easy. It's not hard. You just need to follow my directions. Step 1, make sure that it's in function form. Okay? Are both of these in function form? They are. The first one says y equals 2x minus 4. The second one says that y equals negative 3x plus 1. Both of those things are equal to y. What does that mean about both of those things? Fritz? They're equal to each other. That means that negative 3x minus 1, negative 3x plus 1 has to equal 2x minus 4 because they both equal to y, right? If I said that Armand is the same height as Fritz and Fritz is the same height as Nikki, what do I know about Armand and Nikki? They've got to be the same height. If this equals y and this equals y, then these two things have to be equal. Good. Now, since I've set these two things up as equal, I'm going to add 3x to both sides. And I'm going to get 1 is equal to 5x minus 4. I'm going to add 4 to both sides. And I'm going to get that 5x is equal to 5. Okay. I know I'm getting close to the end. I'll put on another video in just a second. Divide both sides by 5. And x equals 1. Wait a minute. That's what we got from the graph. X equaled 1. I'm going to show you how to get y at the next video.